Hi, this video is about equations on uniformly accelerated motion. There are three main equations, but I have not explained the derivation in this video because it's really simple. And yeah, these are about uniformly accelerated motion. So if an object is accelerating non-uniformly or if it's in non-uniform motion, these equations cannot be used. Just as a reminder, uniformly accelerated motion is when an object accelerates equally. Like in 5 seconds, it covers 10 meter, and in the next 5 seconds, it's 15 meter, and in the next 5 seconds, 20 meters. See, the acceleration is increasing by 5. So it's accelerating uniformly. Only in such cases, these equations can be used. So there are three main equations. V is equal to U plus AT, S is equal to UT plus half AT square, and V square is equal to U square plus 2AS. Here are the terms. So the first equation is saying that the final velocity of a body is equal to the initial velocity plus the acceleration into the time taken to cover that distance. The second equation is saying that the displacement or distance is equal to initial velocity into time plus half into acceleration into time square. The third says the final velocity squared is equal to the initial velocity squared plus 2 into the acceleration into the displacement. Okay, so these are the three equations, and make sure you learn them really well and they're quite easy. And now I'm going to solve three problems on each one of these equations. Okay, let me just write the equations down over here. V is equal to U plus AT, S is equal to UT plus half AT square, and V square is equal to U square plus 2AS. Okay, so here we have our three equations. So the first numerical, it says a train starting from rest attains a velocity of 72 kilometers per hour in 5 minutes. Assuming that the acceleration is uniform, find 1. the acceleration and 2. the distance traveled by the train for attaining this velocity. Okay, so it says that the train starts from rest. So our U is 0 meters per second, and our V, our final velocity, is 72 kilometers per hour, which can be written as into 5 by 18 to convert it into meters per second. 18 ones are and 18 six are. Wait a minute, 1 second. Okay, so on simplification, we get 20 meters per second. So we have our initial velocity and our final velocity, and our time is 5 minutes, which is 300 seconds. They have asked us to find the acceleration and the displacement, right? So first we have to find the acceleration, we can use the normal formula, V minus U by T, which is 20 minus 0 by 5, which gives us, that's 300 seconds. Okay, so that gives us 1 by 15 meters per second is our acceleration. Now they have asked us to find the displacement or the distance. So I'm going to use one formula for the three problems. So first, let's use the last one. Okay, we have 2AS is equal to V square minus U square, which gives us 2 into acceleration is 1 by 15 into S, we have to find it out, is equal to 20 square minus 0 square, which is 2 by 15s is equal to 400. Now we have s is equal to 400 into 15 by 2. 2 ones are 2 200s are, and 200 into 15 is 15 twos are 30, 0, 0. 3000 meter. 3000 meter is basically 3 kilometers. So we have found out the distance using the third equation of motion. Now let's go on to the second numerical. In this I'll probably be using the second equation of motion, this one. Okay, so it says, the brakes applied to a car produce an acceleration of 6 meters per second square in the opposite direction to the motion. If the car takes 2 seconds to stop after the application of brakes, calculate the distance it travels during this time. Okay, so a car is moving and brakes are applied. So it means that we can't take the initial velocity as 0 because it's not at rest. It's not starting from rest. So let's see, we have been given that the acceleration is minus 6 meters per second square because it is in the opposite direction to the direction of motion. And we have also been given the time, t is equal to 2 seconds, and it takes 2 seconds to completely stop, to come to rest, right? So the final velocity v is 0 meters per second. Now we have a, t and v, right? Let's use the second equation for this. S is equal to, no wait, actually first we have to use the first equation to find out the initial velocity, because we know v and we know a and we know t, right? We need to find out u first. V is equal to u plus at. V, which is 0, is equal to u plus minus 6 into 2. 0 is equal to u minus 12. U minus 12 is equal to 0. U is equal to 12 meters per second. So we have our initial velocity, which is 12 meters per second. Now let's use the second formula to calculate the distance, because that's what they have asked. S is equal to ut plus half at square. S is equal to u, which is 12 into t is 2 seconds, plus half into acceleration is minus 6, and half, okay, t square into 2 square. Okay, so we have 12 into 2 is 24, plus, let's just write this as 4. 2 ones are, 2 twos are, minus 12. We have 12 meters. So the distance traveled by the car before it completely comes to rest is 12 meters. So that's our second numerical. One last numerical and then we are done. Okay. So the last one, it says, a car accelerates uniformly from 18 kilometers per hour to 36 kilometers per hour in 5 seconds. Calculate the acceleration and the distance covered by the car in that time. Okay, so they say that the initial velocity is 18 kilometers per hour converted into meters per second, and we get 5 meters per second, right? And they have given us that the final velocity is 36 kilometers per hour. On converting it, we get 1s are, 2s are, 10 meters per second, right? So that's our initial velocity and that's our final velocity. And they have given that the time taken is 5 seconds. We have to find out the acceleration and the displacement covered before it, distance covered when it comes from 18 to 36. Okay, so first the acceleration, use the normal formula v minus u by t, which gives us, use the meters meters per second thing. 10 minus 5 by 5 seconds, 5 by 5, which is equal to 1 meters per second square, is our acceleration. Now we have to find out the distance, right? So let's use the second formula because that's the most direct one. S is equal to ut plus half at square. U, what's our u? 5 into 5 seconds plus half into 1 into 5 square. Okay, wait, let me just erase it. Yeah, so we have 5 into 5 plus half into 1 into 25, which gives us 25 plus 25 by 2, which is into 2, 50 plus 25, 75 by 2. 2 ones are, 2 threes are 6, 1 remainder, 2 sevens are 14, 5. So that's 37.5 meters is the distance traveled. Okay, so this ends our video. These are the three equations on uniformly accelerated motion. Thanks for watching. Bye.